So to determine the points of intersection, the coordinates of intersection, we need to let the equations equal each other first. So I can see here that it's going to work out to be quadratic. So I'm going to first take this over to the other side. So x squared minus 4x is equal to 0. Now I can factorize an x out of that equation and apply null factor rule to let each side of the brackets equal to 0. That will give me that x is equal to 0 and x is equal to 4. So there are going to be 2 points of intersection here. Now, to find the coordinates of intersection, I just need to substitute these 2 answers back into one of the equations. Now, it doesn't matter if you put it into fx or gx. So we're going to put it into fx because that one comes first. So 0 squared is 0, meaning that that first coordinate is at 0, 0. When I substitute 4 into that equation, 4 squared makes 16. So that's going to give me the answer of 4 and 16. So they are the 2 coordinates of intersection. Now, when I'm using these equations to calculate the area enclosed by a graph, all I need to do, the bigger number goes on top, so we're integrating between 4 and 0. Now I need to think about the equations that I've got. I've got a straight line and I've got a parabola. Now, because it's x squared, that means the a term in front there is 1, or I could also say that that's positive 1. So this parabola is going to look like a happy face. Now, we know the points of intersection are here and here at 0, 0 and 4 and 16. So I can say that between those 2 bounds, the linear equation, this one here, is the top. Now, that's important to identify because we want to do the top equation minus the bottom equation because that is going to get us the area that is represented there. So we're going to be integrating that with respect to dx. So integral for 0, our top equation is 4x, and we're subtracting x squared, and we're going to integrate with respect to x. Now, when I integrate this function, I'll end up with 4x squared divided by 2 minus x cubed over 3, and we're going to substitute 4 and 0 in. These 2 can simplify further to make it 2x squared. So now I'm up to the part where I can substitute into this equation. So 2 bracket 4 squared minus 4 cubed divided by 3. Now, when I substitute 0 in here, it will make that term 0. And when I substitute 0 in there, it'll make that term 0. So it'll just be subtracting 0 in this case. Okay, so now we're going to have to do the rest of it manually. So 4 times 2 makes 16, times 2 again makes 32. And then I'm subtracting 4 to the power of 3. So 4 times 4 equals 16, times 4 again makes 64. Now we're going to do 64 divided by 3. So I'm going to end up with a weird fraction here. So I'm just going to leave it like this for the moment. 64 over 3. Okay, if I did go through and continue with this, 3 goes into 6 twice, and then I have 1 there with 1 over 3 remaining. So if I was going to do the 32, I could subtract 21 and 1/3. 32 minus 21 is going to give me 11, and then I need to minus 1/3, which would give me 10 and 2/3. So that's going to be our answer. If I wanted to leave it like this and do it in fractional form, it just means that I would make the denominator the same by multiplying the top and bottom by 3. So that's going to give me 32 times 3 will make 96 over 3 minus 64 over 3, which is going to be equal to 32 over 3, which is going to, if I convert that, it'll be 10 over 2/3. Doesn't matter which way you do it, but you are going to have to be able to do this manually. Now, the other thing is, don't forget that this is units squared. We are looking at area.